Welcome back. My name is Satyajeet Sahu, and we are in monsoon series. Okay, we are in monsoon series. So, in monsoon series, we are solving the numericals for GATE, and we are seeing the important topics which they can ask. Okay, so just some technical error is there. We'll rectify it, and then we will continue. Okay. Good evening, Diya, Ranjan. Good evening, Nayan. We are facing some technical issues. Okay. We'll start the lecture in 1-2 minutes. Okay. Should I close this and again open? So this B mix I should close and open. Okay. Let us see if the error is rectified or not. Yeah, so the error was rectified. So we have our technical team. Hardik was there and he was able to make the things work. So all the students, they can thank Hardik in the comment section. Okay, they can thank Hardik that there was a technical fault and he was able to rectify it. Okay, so all the students, I request all the students that once they write thank you Hardik, and then we will continue the class. Okay, चलो एक बार आप हार्दिक लिख दीजिए थैंक यू हार्दिक and then we'll start the class. Okay. Okay. Okay, very good. Okay, so now today's topic is earth pressure in cohesive soil. So in middle of a lecture series for Geotech, okay, so on 18th on Monday we covered permeability in layered soil. Then we covered active earth pressure in cohesionless soil. And today we are going to see what? Cohesive soil. We are going to see what? Cohesive soil. Means what? Your cohesion is non-zero. Now before going, a short introduction about myself. My name is Satyajeet Sahu. I have done my BTech, MTech both from IIT Kharagpur. I have been selected into many of the PSUs through GATE only. I have 10 years of teaching experience and more than 15 states I have traveled to teach. I teach all the civil engineering subjects and also teach what? General studies for your ESC prelims. Okay, so let us start today's class. Suppose this is a retaining wall. Okay, okay. Now, this is known as what? The soil behind the retaining wall is known as what? This is known as the backfill. Known as what? Backfill. And when I am saying that it is cohesion, it's cohesive, I am saying what? It is cohesive. That means what? The C is non-zero. So the cohesion is non-zero, and we have the angle of internal friction also non-zero. Okay. Now we know that the coefficient of active earth pressure is what? 1 minus sine phi by 1 plus sine phi. This is what? This is the coefficient of earth pressure. Right? Now, if we see the active earth pressure PA at any depth, suppose Z. Okay. If I ask you how to find out the active earth pressure at any depth Z. So first of all, you can easily find out the vertical stress, right? At this point, if I ask you to find out vertical stress, you can find out vertical stress, the effective vertical stress. It is what? It is effective vertical stress. It is effective vertical stress. So if you know the vertical stress, okay, if you're interested in finding out this horizontal stress, and you see this active earth pressure is the horizontal stress. So I can say this active earth pressure PA, the formula is very simple. You take the vertical effective stress, okay, multiply Ka, okay, then minus 2C root K. Yes, this is what? Minus 2C root Ka. Very easy. And Ka, what I told, it is simply what? 1 minus sine phi by what? 1 plus sine phi. Yes, it is 1 minus sine phi by 1 plus sine phi. This can be also written as tan square 45, tan square 45 plus, not plus, minus 5 by 2. How? How it is there? You see, how to remember this relationship. If you put phi is equal to 0, how much you are getting? Phi is equal to 30, how much you are getting? Ka. From the first equation. From the first equation you are getting what? 1 minus sine 30 is what? 0.5 and 1 plus sine 30 is what? 1.5. So this is how much? 1 by 3, right? This is 1 by 3. And if you are putting phi is equal to 30, what is tan square 45 minus 5 by 2 means what? 30 by 2 means what? 15. And 45 minus 15 is 30. What is tan square 30? What is tan square 30? You write down. What is tan square 30? What is tan square 30? I want to see the students are active or not. It's a very easy thing. I'm just asking you to see that are the students active or not. What is tan square 30? Yeah, it is 1 by 3. Yes. So you can remember this formula. Many students, get confused. Just remember this formula. If you are finding tan square, I told. So tan 30 is 1 by root 3. So tan square 30 will be 1 by 3. Okay. So this formula you can remember in this way. You can remember in this way. Okay. So this is your Ka I got. Now, if this is the active earth pressure formula, okay, active earth pressure formula, and gamma is gamma and at a particular depth, what will be your vertical stress? Your vertical stress will be equal to gamma into Z, right? Yes, this is your vertical stress at any depth, Z suppose. So what will be the vertical stress at top? Tell me, you will tell, I will not tell. What will be the vertical stress at the top? What will be the vertical stress at the top? Tell at the top and at the base of the retaining wall. Suppose the retaining wall has a height of h. So at top it will be 0. The vertical stress is 0. Right? At bottom up, or I can say base, what will be the value? At base, what will be the value? At base, what will be the value? Tell me. At base, what will be the value? Base. The base of the retaining wall. Okay, it will be gamma into h. It will be gamma into h, or unit weight into h. So now, if I ask you, what is the active earth pressure at the top? The active earth pressure at the top, the formula is what? Ka into vertical stress minus 2C root Ka, right? So what will happen? The vertical stress is 0, right? Right? So only this minus 2C root Ka will remain, right? So only this minus 2C root Ka will remain, right? At the top. Now when I'm seeing at the bottom, it will be simply what? Ka into the vertical stress, that is how much? Gamma into h minus 2C root Ka. So you can see that at top, I am getting a negative value in cohesive soil. The earth pressure is what? Negative. And bottom it is positive. Bottom it is positive. So if I draw the stress distribution, then I'll get something like this. Then I'll get something like this. Here, I am getting what? Minus 2C root Ka, right? And bottom I am getting Ka into gamma h minus 2C root Ka. So if at top I am getting a negative value and bottom I am getting a positive value, That means what? In between somewhere it will be 0, right? Yes. In between somewhere it will be 0. And that is suppose here. Here what is happening? The earth pressure is 0. Yes. Here I can say the earth pressure is 0. And this depth where your earth pressure is 0, suppose I am calling that as Z0. I am calling that as what? Z0. Okay. So if I ask you what is Z0? What is Z0? Z0 is the depth. I'll say Z0 is the depth at which your earth pressure, active earth pressure is 0. Very easy. Active earth pressure is 0. Now your active earth pressure is 0. Can I find out this depth? See, there are formulas you can remember. But if you forget the formula also, then also you can find out. How? You see, your active earth pressure is what? It is Ka into vertical stress minus 2C root Ka, right? And this is equal to 0. And you see, your vertical stress is what? Simply gamma into Z minus 2C root Ka. Yes. And when it is 0, then depth is Z0. So I can put here Z0. So this is equal to 0. So from here what I can say? Ka gamma Z0 is equal to 2C root Ka. Now you see what will happen? This will get cancelled. And from here the Z0 will be how much? It will be 2C by gamma root Ka. See, many students get confused in this formula, right? They will get confused, sir, it is 2C by gamma, or C 2 gamma by C, or K root, or only K. Now you will never forget this formula, and even if you forget this formula, then no issues. Even if you forget the formula, then also no issues. If you just remember the active earth pressure equation, equate it to 0, you will get the answer. Right? Very straightforward. This is known as also what? This is also known as depth of tension cracks. This is also known as depth of tension cracks. Why it is known as depth of tension cracks? Why it is known as depth of tension cracks? Because you see, here the earth pressure is negative. See, below it is positive. Here it is negative. That means it is not pushing the wall. Actually, it will try to be removed from the wall. So some kind of this tension crack will develop here. Yes. So here tension crack is developed, and this is also known as what? Depth of tension crack. So in the examination, what all things they can ask? First of all, they can ask you this equation. Now this equation has various forms, and they ask that also. Let us see what forms they ask. First of all, the depth of tension crack Z0 is equal to 2C by gamma root Ka. I told you that Ka is equal to how much? It is actually equal to 10 square 45 minus 5 by 2, right? So when I take a square root of this, what I will get? I'll get another form of this equation. Thus Z0 is equal to 2C by gamma what? 10 45 minus 5 by 2. 10 45 minus 5 by 2. Yes. Hello Salgar. Okay. Now you see, there is another form of this equation also. You see, they in the examination, they will give you 4 options, and you always get confused. But you will not get now. You see, 1 by 10 45 minus 5 by 2 is equal to 10 45 plus 5 by 2. Yes or no? Yes. Just put 530 degree. If you put 530 degree, this term will be what? 1 by 1030, right? 45 minus 15. And this will be what? 10, 45 plus 15, 1060. Is this not correct? It is correct, right? Yes. 10, 1 by 1030. 1030 is what? 1 by root 3. That gives me what? Root 3. And that is what is 1060, right? Yes. So I can say that this relationship is valid. So you see, another form of this equation is what? 2C by gamma 10 45 plus 5 by 2. Now, any form of this equation they ask you, you can easily answer in the examination. They will give you 4 options. In one more question, they put a lot this type of question. They will give you 4 options and you thoroughly get confused which one is the right answer. But now you will not. Okay. Now you see if it is purely cohesive. See what is the meaning of purely cohesive? Purely cohesive means what? Your phi is 0. If your phi is 0, how much will be Ka? Ka will be 1 minus sine 0 by 1 plus sine 0. That is what? 1. If that is the case, very good Aftab. That is the case, this Z naught will be how much? Simply 2c by gamma. So you see, all these type of questions might be asked in the examination. For example, I will give you a question. Please answer this. I am giving a question that if your C is equal to 60 kilopascal or kilonewton per meter square, your gamma is equal to 20 kilopascal, okay, and your phi is equal to, suppose I am giving 26 degree, okay. Find depth of tension crack. Find depth of tension crack. Come on, find the answer fast. It's a very straightforward question. The first thing they can ask is what? Your expression. The second thing they ask is what? The numeric. So I'll also solve with you. You solve. Let us see who will solve first. So 2c by gamma root Ka, right? So this is equal to 2c. 2 into c is 60. Divided by gamma is how much? 20. And then root, what is your Ka? Ka will be equal to 1 minus sine 26 divided by 1 plus sine 26. See, we are solving all the basic questions, but they are very important. So sine 26. So sine 26 I'll use, okay, I'll subtract 1. So this is 0.562 divided by I'm getting almost 0.391. Okay, somebody also found out the answer. Okay, I'm getting Ka as 0.391. So I'll put here 0.391. Let us see how much I'm getting. This is 120 divided by 20 divided by root 0.391. I'm getting an answer of almost 9.6, I can say. I'm getting almost what? 9.6. Okay, so a very straightforward question. It's a very straightforward question, right? They might ask a question like this, you see. They might ask a question like this, that in a purely cohesive soil, depth of tension crack is 2.5 meter. Depth of tension crack is 2.5 meter. If gamma is equal to 18 kilonewton per meter cube, find the cohesion. Find cohesion. Let us see how many are able to solve fast. Find cohesion in kilopascal or kilonewton per meter square. Very straightforward question. Let us find out fast. They're asking the depth of tension crack. Okay, very straightforward question. Find out. It's mentioned purely cohesive soil. From that you should be able to. Salgar found. Very good. Very straightforward question. You see, the depth of tension crack in this case is what? Simply 2c by gamma. That is equal to what? 2 into cohesion is what? That is what you are going to find. Divided by 18. And this is given what? This is given 2.5. So this is 9. I will just multiply 9 into 2.5. I'll get how much? 22.5. There was no need of a calculator also. Okay? Because your phi is 0, so K is 1. So this type of very simple question, identifying the correct option, okay, or simple numerical they can ask. This is the first thing they will ask. Okay, this is the first thing they will ask. And this is what? This is your stress distribution. This is your active stress distribution or active earth pressure distribution. The next thing they can ask is what? To find out the total active pressure force. Now, how to find out the total active pressure force? Let us see. Okay. So we have got this minus 2c root Ka. And this we have got how much? Ka into gamma h means Ka into vertical stress minus 2c root Ka. So if I am interested to find out the, sorry, I'll have some water. See, if I'm interested in finding out the total active earth pressure force, okay, the total active earth pressure force will be simply the area of the distribution diagram, right? But that will also depend on two things. What is the first thing? The first thing is if the tension cracks are formed. If tension cracks are formed. See, if tension cracks are formed, what will happen? For this Z0 depth, you see, for this Z0 depth, the backfill or soil will not be in contact with the wall. If it is not in the contact, then what kind of pressure it will exert? It will exert no pressure. So I can say that in that case, this top distribution will vanish. Everybody understood? I'll again repeat that if we have the formation of tension cracks, then this part of your retaining wall is not in contact with the backfill here. वो contact में ही नहीं है. It is not in contact. If it is not in contact, means what? The distribution will not be valid now. So I can just remove this distribution. If I remove this distribution, now the distribution is very simple. This dimension is this, right? What will be this dimension? Tell me. What will be this dimension? Is it a triangular distribution? This dimension we know. This we have found out, right? Now tell me what will be this dimension? Can anybody say? The total height is h. What will be this dimension? The height of this triangular distribution, what it will be? The height of the triangular distribution, what it will be? The height of the triangular distribution, what it will be? Very simple. Please mention in the comment section. What will be the height? Very good. H minus Z0. H minus Z0. Game over. No need to remember any formula. Again I am telling, no need to remember any formula. This is the distribution. If you can draw the distribution, take the area of this. The area will be the total force. The area will be the total force. Very easy. For example, if I say, I'll give a question. Suppose I am telling that your C is equal to 20 kilopascal. And suppose phi is 30 degree. Phi is 30 degree. I can say Ka will be 1 by 3. 1 minus 0.5 by 1 plus 0.5, that is 1 by 3. Okay. Suppose gamma I am giving as 18 kilonewton per meter cube. Okay. I am giving 80 kilonewton per meter cube. And suppose this height of this particular retaining wall is 8 meter. It is what? 8 meter. It is 8 meter. Now, I need to just draw this diagram, right, properly, and then I can find out the area. So, if it is written tension cracks are formed, if in the question it is written tension cracks are formed, then this will be the distribution, right? This will be the distribution. If this is the distribution, how to find out this dimension? This dimension is simply h minus z0. So first of all, give me the value of z0, then it will be 2c by gamma root Ka. That will be equal to 2 into c is how much? 20 divided by gamma is how much? 18, and this is Ka is 1 by 3, so it will be root 1 by 3. So tell me, what is this height you are getting? What is this depth of tension crack you are getting? Please tell me. What is the depth of tension crack getting? You are getting 3.85. Let me calculate. 40 divided by 18 and then multiply by root 3. I am getting 3.85. This is 3.85 meter. If this is 3.85 meter, this is how much? 8 minus 3.85. That is how much? I can say 4.15 meter, right? This is 4.15 meter. Very good. Now, what is the vertical stress at this bottom? It will be simply Ka 1 by 3 into gamma into H. H is how much? 8. To gamma into H minus 2C root Ka. Can I find its value? This will be 6. So 48 minus, it will be 48 minus 40 by root 3. How much are you getting this value? 40 by root 3. How much are you getting this value? This value is 40 divided by root 3 and then 48 minus this particular value. I am getting 24.9. How much are you getting? How much are you getting this value? This earth pressure at the bottom. I will calculate that. 2C root Ka. Oh, sorry. It's not root K. This is actually 2C. Yeah, correct. Root 3 only. How much are you getting? 24.91. Very good. Almost 24.91. So you see, no need to remember any formula. You just need to know how to draw this distribution properly. Game over. So total active force will be simply the area of this half base into height. And you can do some approximations also. So this total active force will be how much? 24.91 into 4.15 divided by 2. I am getting 51.7 almost. 51.7 kilonewton per meter. And as I told, ladies and gentlemen, no need to remember formula, only simple concept. So if they ask you find out the total active force when tension cracks are formed, just remember how to draw the distribution. Okay, this one is H minus Z naught, and this is actually what? Actually Ka into vertical stress minus root 2C root K. That's it. No need to remember any other formula. So this we understood when the tension cracks are formed. Now let us see when the tension cracks are not formed. See, this was the original distribution, right? This is the original distribution. Suppose I am telling that tension cracks are not formed. I am telling what? Tension cracks are not formed. If tension cracks are not formed, just observe this. This is a negative distribution and this is a positive distribution. Now when you are finding out the area and adding it, see, total force is what? You have to take the area. Now this is negative, right? And this is positive. That means this negative will cancel equal amount of area from the positive. Yes. See, I told that to find out the total force, you have to take the area of the distribution. It is negative area, so it will cancel same amount of what? Same amount of positive area. And that area will be same as this. Like this. Understood? So this negative will cancel this positive and net distribution will be this one only. Yes? I will again repeat that we have this negative area, we have this positive area. Right? Now what happened? Since the tension cracks are not formed, so this distribution will cancel some amount of the positive distribution and that will be same area. So this part it will cancel and I can say I'll be left with only this part of the distribution. Yes, I'll be left only with what? This part of the distribution. This diagram, everyone is clear how we got this diagram? Yes, everyone is clear. You see, if this is Z naught, by symmetry, because the equal area, right? Cancelling equal area, that's what? This one is also Z naught, right? Now you see, this is minus 2C root Ka. So this will be what? This value will be 2C root Ka plus value, right? Yes. So this negative one will cancel this positive one. Yes. And then I will be left with only the green distribution. Now that is very easy. This green distribution is a trapezoid, right? With the top stress how much? 2C root Ka. Why 2C root Ka? Because of symmetry. And this base is how much? Ka into vertical stress is how much? Gamma H minus 2C root Ka. Now tell me what will be this height, tell me. What will be this height now? What will be this height of this trapezoidal distribution left? If suppose total one is h, what is this height left? Tell me. What is this height left? What will be this height left? That will be simply h minus 2z naught. Very simple. That will be simply h minus 2z naught. Game over. Game over. So I can say now, this is it. What is remaining? The other one gets cancelled. You see, this top one will cancel this bottom one. So I will be left with only this one. And as I told, no need to remember any formula. You know how to draw the distribution? You can easily find out the value. H minus 2z naught. And this is what? 2c root ka. If you are seeing the same question as previous one, and I am mentioning that tension crack not formed. Tension crack not formed. Okay? Second case, the first one was what? If you remember, first one was what? Tension cracks are formed. Now here, it is not formed. If it is not formed, we saw this is the net distribution. So if I am interested to find out the total force, I have to just take area of this. Now this is how much? This is 40 by root 3, right? This is 40 by root 3. 40 divided by root 3. That is equal to, I can say, 23.1. This is how much? I can say 23.1. Sorry. This is 23.1. What was this base value that we got earlier also, right? That was 24.91, right? That was 24.91. Yes. Everybody got these two values. This is simply 2c root ka. And ka is 1 by 3. And c was your 20. Right? So if I take this value, this is 40 divided by root 3. And then the base one was how much? 24.91. Everybody getting this value. Now what will be this height? Tell me the value of this height. This top width we got. This bottom width we got. Okay. What is this height? Tell me. What will be the height value? Tell me. Tell me the value of this height. Tell me the value of this height. What is the value of this height? Tell me. Let me calculate also. It is 0.3 meter, right? Yes, it is 0.3 meter. It is 0.3 meter. Why? Because 8 minus 2 into z naught. 2 into z naught means what? Z naught was 3.85. So we'll get how much? 0.3 meter. So now if I'm interested to find out the total active force, very easy. It's a trapezoid. So half sum of parallel sides, okay, into the height. So what is the active work pressure now? Tell me when the tension crack is not formed. When the tension crack is not formed, what is this height? It is simply the force. Simply take the area. Okay, if you take the area, you're getting how much? 7 point something. Let me calculate also. See, there will be minor variation in calculation. That is fine, because everybody is taking some approximation, so we'll get some different values. So you're getting almost 7.2 kilonewton per meter. Because all these forces we find out what? Kilonewton per meter. So it's so easily for tension crack not formed, and for formed we are able to find out without going into so many complicated formulas. Just know how to draw the distribution. Just know how to draw the distribution. Now they ask you another thing in this. You can see that the top part here is cancelling the bottom part in case of tension cracks not formed. And this height they call is at what? As the critical height. They call is at what? Critical height. You can see that if you are not providing any retaining wall here, that means you are not supporting anything. Suppose you are just providing like this. You are providing retaining wall up to this height only. Okay. If you are providing retaining wall up to this height only, then also there will be no problems or no issues. Why? Because what will happen? The top part will cancel the bottom part. Therefore, I can say there will be no net earth pressure. Yes. So this critical height is also known as what? It is also known as the maximum vertical cut or maximum depth of vertical cut, or I can say maximum depth of unsupported vertical cut. This is what? Maximum depth of unsupported vertical cut. So I can say up to this height you can cut in the earth and there need not be you need not provide any support. Understood? So critical height finding is very easy. It is just twice of your Z naught. Like in this question, if they give you all these values, you can find out Z naught. Like in this question, suppose, in this question, what was your depth of tension cracks? It was 3.85, right? And same question, if they ask you find out the critical height, it is just twice of that. It is just twice of that. I can say how much? 7.7 meter, right? 7.7 meter. You see, in such a small time, I think hardly 30 minutes, we are able to solve so many questions and so many things, right? We are able to solve so many questions and so many things. So this is how we should learn engineering with the concepts, and this is how you solve questions in the GATE also. You have to remember that in the GATE, if you are going for just memorizing the formulas, it won't do, because there are so many formulas. Yes, some formulas we do need to remember. Some formulas we do need to remember, but that is not sufficient, because you need to know the concepts also. If you know the concepts, then you can easily solve this kind of questions. Let us see now. Summarize the lecture. You see, when the tension cracks is formed, this is the distribution, right? Tension cracks formed, right? Tension cracks formed. So this we saw, this is the distribution, right? And if I say tension cracks not formed, this is the distribution, right? Tension cracks not formed. So if the examination, if they ask you to find out the difference in the forces, difference in the earth pressure. Now one thing is there, you can find out, you see, you can find out when not formed, suppose 51.7, okay, sorry, means formed 51.7, and then not formed, how much you are getting? You are getting 7.2. So you can find them individually and take a difference. But that will take time in the examination, right? If they ask you difference, you have to find both and take the difference. See, if they ask you only find when they are not formed or formed, you can find individually. If they tell you find out the difference, then you have to find both and then take the difference. Now that is going to be little lengthy. So we should be smart, right? We are smart. So what you will do, see, you see, can I say the difference between these two is this orange one, right? You see, the difference between these two is this orange one, right? Sorry, this is the orange one difference, right? You see, this is the difference. You see, this is the difference. If this is the difference, then this difference you can easily find out. What was this value? This value was 2c root Ka, right? Yes. And this is anyhow Z naught, na? This is Z naught. You see, this is also Z naught, but this is also Z naught, right? So, what will be this area? This area or this difference? This difference will be equal to, simply what? Half base into height. So, base is 2c root Ka and height is what? Z naught, and Z naught is what? Z naught is 2c by gamma into root Ka, right? So you see what happens, this root Ka get cancelled, this 2 get cancelled, I get how much? This difference of active earth pressure force, right? This difference of active earth pressure force, is equal to how much? Simply 2c square by gamma. Easy. So you see, if I ask you the same question, find out difference in the earlier question, find out difference, 2c square by gamma if you straightforward put. So this is 2, c was how much? 20, na? So 20 square and gamma was 18. How much you are getting? Let us find out. This is 2 into 20 square divided by 18. I am getting how much? 44.4 kilonewton per meter. See, if you are not finding like this, if you are finding them individually, then what I can say? If you are finding individually, then with tension cracks, I was getting the total active force as how much? I was getting 51.7 kilonewton per meter. Now, without tension cracks, I was getting this value as 7.2 kilonewton per meter. Now, if you find the difference, how much you are getting? You are getting 44.5, right? You see, you are getting 4.5 Newton per meter, right? Yes. Now you see, if they ask you the difference, tell me, finding individually and taking the difference, is that a wise thing? Or directly using this 2c square by gamma is a wise thing? Obviously using this 2c square by gamma is a wise thing that smart people will do, right? Like you and me. Okay, so therefore all these smart things we need to understand, and then you can easily solve gate question, and these all things are very easy actually. Okay, so you need to attend these lectures very nicely. Okay, and you see, so easily you are able to solve the questions, right? You can see so easily we took the difference by just understanding the distribution. Yes, but then you will ask me, so then why you taught this with tension crack and without tension crack, and then the difference? Directly you could have taught us the difference, right? Because in the examination always they will not ask you difference. They might ask you sometimes that find with tension crack, only the force with tension crack, or they might ask you find without tension crack. Then you have to individually find out, right? Yes. Therefore I taught you how to find out using both the things. Okay, because they might ask you to find out the individual values, okay, or they might ask you the difference. Individual values I taught how to find out. If they ask you difference, directly go for this. So this was a lecture. Hope you all enjoyed this lecture. In this we learned so many things, right? We learned that what is the depth of tension crack, right? They ask you the depth of tension crack, Z0. Then we learned what? We learned the critical height, or I can say the maximum height of unsupported vertical cut. It was equal to how much? 2 times the Z0. Then we saw to find out the total active earth pressure force with tension cracks and without tension cracks, right? Even they might ask you that the distribution. Tell me, with tension cracks, it was trapezoidal or triangular? The stress distribution with tension cracks, it was trapezoidal or triangular? With tension cracks. With tension cracks, trapezoidal or triangular? They might give you 4 options like this. They will give options like this, you see. They will give options like this, or they might ask you the options like this. Last option supposes or none of this. Triangular, you see, you get with tension cracks, you get this because the top is not in contact, na? Yes. And we also learned how to find out without tension cracks. Okay, without tension cracks, how to find out the total active force we learned. Okay, this was this distribution one, last one, right? The trapezoidal one, right? And then we saw the difference was so easy, right? The difference also we learned. And even if you forget the difference, suppose you are getting confused, it is 2c by gamma or 2c square by gamma. You just remember this, right? You can easily find out if you just remember distribution. 2c root Ka and this is what Z0 means, 2c by gamma root Ka. Multiply means area, take the area, you will easily get this formula, right? Right? This is the area of this. This is what? This is the area. Yes. So you see, by just understanding the basic concepts, you can answer such questions. So for such basic concepts and all, please download the Byjus Exam Prep app. There I have taken lot of lectures on Geotech, not a lot of completed subjects. I have completely taught the subjects of Geotech, environmental engineering, concrete structures, open channel flow, yes, strength of material, fluid mechanics, okay, and other esteemed faculties also have taught. So you can see that this is from the app that I have taught all these things in more details. Okay, anyhow I am teaching details on YouTube also, but more details and more practice, more numericals I have solved there. Okay, so we completed layered soil, permeability in layered soil. We completed earth pressure in cohesionless, earth pressure in cohesive. Tomorrow at 6 p.m. Tomorrow at 6 p.m. I will be taking bearing capacity of soil. Okay, we'll learn what? Bearing capacity of soil tomorrow at 6 p.m. So please stay tuned and come on YouTube live. Okay, on your Byjus Exam Prep official YouTube channel. Okay, so tomorrow we have two sessions. Okay, at 11 a.m. in the morning. Okay, 11 a.m. in the morning, we will be having Geotech objectives for HPCL. HPCL exam is coming, yes. So we'll have objective session for this. Now these objective sessions will be also helpful for any PSU exam. It will be helpful for your upcoming SSC JE prelims. Okay, SSC JE prelims. It will also be helpful for your what? For your GATE 1 mark. So tomorrow from the topic of consolidation and shear strength, okay, consolidation and shear strength, we will solve 50 objectives in 1.5 hours. And the objectives are originally framed by me. Okay, 90 minutes, 50 objectives we will solve and discuss also. Not only solve, we'll discuss the objectives also. These all objectives are designed by me, and in these 50 objectives, I will be covering what? Consolidation and shear strength. So thank you very much for attending this session. Tomorrow at 11 a.m. this session is there. Okay, and evening 6 p.m. as I told, we will be having what? Your bearing capacity of soil. Okay, and 4 p.m. in the Byjus Exam Prep app. Okay, you can download the app. Okay, Byjus Exam Prep app. There also I will be taking a session on PERT. So many sessions are going on. So do attend. So tomorrow we have 3 classes. 11 a.m. yes, objective practice. 4 p.m. PERT, and 6 p.m. your bearing capacity. But this will be in YouTube. This will be on YouTube. This will be on the official app. Thank you very much. If you have any queries, you can always message me on my number 8826726300 related to studies only. Okay. Thank you very much. See you tomorrow morning. Thank you.